Hey, hi everybody. Welcome to Lightning Talks, co-hosted by Our Ladies Philly and Our Ladies DC chapter. So I'm joining you guys from Our Ladies Philly. We have a few organizers on the call from both of these chapters. So welcome. If you haven't already, please post where you're joining us from in the chat. So also throughout this presentation, we have slido.com for Q&A. So make sure to post your questions on there. We have another organizer that will be keeping track of those. Our Ladies is a worldwide organization. Our goal is to promote gender diversity in the art community through these meetups and participants like you all and our presenters. And this is a friendly and safe environment. So you can review the code of conduct at this link as well. And a few announcements. So we have a few future events coming up on July 13th. There will be a presentation by Julia on 3 reasons to use tidy models. July 20th, this will be in person in Philadelphia. It'll be an intro to GitHub workshop. And also upcoming art conferences. There are these links to join, one in Boston and another one in Chicago also coming up. All of these Our Ladies meetups are posted in the meetup page if you guys want to go over and look over that. And a few ways to get involved. Slide. So yes, a couple of ways to get involved. You can join our Slack community, Our Ladies Philly Slack, and you can also subscribe to our YouTube channel. This recording will be posted to that YouTube channel. Or you can volunteer as a speaker or mentor. It's a friendly environment, especially if you're trying to practice for an upcoming conference or for a talk presentation. This is a great way to practice in a very safe and friendly environment. And a brief thank you to our sponsors, Independence Media, our consortium, and O'Reilly Books. So our speaker lineup for today, and I'll have my colleague Jessica introduce them. This is the lineup that we have for today, very exciting. And we'll get started. On to you, Jessica.
Hi, everyone. Welcome to our Lightning Talks event today. I'll be introducing each speaker before each talk. So our first speaker today will be Priyanka, and the title of Priyanka's talk will be Data Wrangling in R for SaaS Users. And this talk will be about how to make it easy to translate legacy SaaS codes with R. So I'm going to go ahead and stop sharing my screen and let Priyanka take the floor. And one note before we start, thank you again to all of our speakers. We're all really excited to hear what y'all have to say.
Is my are my slides visible?
They look perfect.
Yes, they look good.
Cool. So I will just start right away. Just for the starters, hi everyone, I'm Priyanka. I currently work at Prokogya as a senior art developer / analytics consultant. Here are a few ways you could connect with me on LinkedIn or Twitter, just to drop in a hi, or there are links to my GitHub and blog, to if anyone's interested in seeing a couple of, side projects that I do. And in fact, my blog is actually work in progress. I have a lot of posts which are in the draft stage, and hopefully soon I should be publishing them. So let's get started. So for today's discussion, our focus is going to be understand, as the title says, we will talk about data wrangling in R, especially for SaaS users. But let's discuss, I think the who in this case would be, or the ideal audience for this discussion would be, a spectrum of people that could fall into this, who could probably find this useful. So maybe a person who knows SaaS really well and is on the edge if they should learn R or not. And or probably on the other hand, someone who's knows R, proficient in R, but has never worked with SAS, and has been handed over a project where they need to figure out what is going on in that code, and they need to probably translate it. So people of these different skill set and anyone in between is who could probably have some takeaways from this discussion. To think about why. And I think when I was writing this, I thought, well, if you're all here, I mean, it's for you. And I don't think I have any reasons to mention here, but still, if I had to, because we know how strong and how evolved our programming as a tool is from the time it came out in the academics to this time, how strong it has become and how it has evolved. And I think most important of that being it's an open source, a free tool. But for me per se, and I think Hebah can vouch for that the strong sense of community that I have experienced, and I would love for everyone else to experience. If it was in my power, I think I would move everyone to start coding in R. And to think about how, and I guess the rest of the conversation is going to be focused on how we do that transition, from being a SAS user or a SAS programmer to, being able to move things around and writing codes in R. So to begin with, to sort of get a sense of how we would do things around, it's sort of essential to look through, the data analytics pipeline that, sort of any project would, in essence, would go through. You would start with getting your data into the system. You would have to play around with your data, which is essentially what's called data wrangling. In several situations, at the exploration stage, at the final presentation stage, and a lot of places in between, you would end up doing a lot of data visualization and plotting. Then after a certain point, you would start to think about how you'd want to automate your stuff. And in some advanced projects, you might look into modeling and deployment as well. So my talk would be a success if I could convince, all the SAS users, or at least a few of those who are attending today, or maybe potentially who see this on YouTube later, to start feeling at ease, thinking about moving their code with ease in R. And well, if in case you don't, please come back and reach out to me on the ways I've mentioned that you can connect with me. I'd be happy to maybe translate this into a longer workshop, or see how I can help. So let's just get started. So I think I wanted to go back and highlight that. So these are the different phases of or parts of analytics pipeline that I mentioned. So although I have actually put in an example for importing data, that's one of the slides that I'm going to skip, because as the title says, I'm going to focus. I'm going to keep the focus on wrangling data, because that's a huge list of things to discuss anyways. And then, time permitting, I will also talk about a few things about automation. So that kind of gives us a range of flexibility that that R can provide us in achieving things that we would want with a lot more efficiency. So, if anyone wants to probably refer this can be a useful text for them as well. Now, before I start talking about all of these examples and show you how things can be either similar in nature in terms of translating your code, or how easier it can be, let's think about what data wrangling is, right? So data wrangling literally would mean anything and everything that you're doing with your data to be able to get to either the report or the model or the visualization that you're trying to get to, which in turn in the ground level as a process, what it really boils down to is working with your columns, whether you're maybe creating a new column, selecting, deselecting, renaming the columns, working with the rows, you're sorting the data, you're filtering it maybe, and then you are, you're joining a bunch of data frames or, tables. So a lot of these things is, sort of what would comprise. So although it's a small word, but it actually, entails a lot of sort of activities in the process. So I've broken it down more or less from the Tidyverse context. So let's take a set of those, and let's work through some of the examples to understand how easy it is to sort of read the SAS codes, and then how to have that translation, how R makes the translation easier, or very intuitive in that sense. And I guess just a sort of just a disclaimer that a lot of this is more Tidyverse ecosystem focused. Some of these things can also be done in base R, but for the purpose of this talk, the focus is gonna be on Tidyverse style. And I think Arati will have a few more guidelines after some of the talks here. So first, let's focus on how, what are the things that you would work with when you're working with columns. You want to maybe create a column, select or unselect a column. So in a SaaS environment, something that you do for working with columns is generally, or even data frames is, it's called a data step. So you can use a data step, use the keywords data and set to work with different data sets and create a new data set, whether you're creating a new column. So in this case, you're just assigning it. Give me a second. All right, I have a guest. So then it's basically just assigning a new object if I were to translate this in R. Now, thinking about keeping a column or dropping a column is similar to saying selecting or deselecting a column, wherein, I could use select, the keyword select, which is a function or it's also sometimes also known as a verb in the Tidyverse context. So if you use minus before a column name, that's basically dropping or deselecting it. And, whichever column you're putting inside your select would be keeping that particular column. You could use, something called regex and helper functions, which allow you to use multiple, multiple column names. So for example, if you have a data frame where you have, for example, 5 columns, which are named similarly in the sense that temp1, temp2, temp3, temp4, 5, and temp5, which probably, relate to 5 observations of temperature or temperature observations for 5 days, for example, right? So in SAS, you do that with a colon operator. A similar approach would be using what's called selection helpers. And in this case, I've used starts with. So when I pass in the string, it would pick up everything that starts with the word temp, and so temp1 to temp5 would automatically be selected or deselected. Sorry, in this case, which is because it's minus here. And then we have a few other functions like contains, ends with, and so on. And then you could, all right. So you could rename the columns with the keyword column in your SAS program. And similar to that, you have a rename function or a verb in your Tidyverse context, and you can, with a slightly different format, you could, rename your columns here. But I think one thing I wanted to highlight here is that this kind of syntax is helpful because for other functions that we use from the Tidyverse ecosystem, like mutate or summarize, this kind of stays as a sort of standard or format where left hand side is the new column that you're creating or even overwriting for that matter. So keeping this as a as a sort of standard that this is what you're assigning it to. So that helps keep it consistent across different functions. With that, I'll move on to, sorry, this is going to be a little bit of highlighting style that I did, and moving on to working with the rows. So really thinking about working with the rows, you really want to highlight 2 functions like sorting or arranging your data and filtering based on certain conditions. So in SAS, it's typically proc sort or sort procedure that you would use. You would mention what are the columns that you want to use for sorting. Same way, you can use an arrange function or arrange verb from the Tidyverse ecosystem to look at all those columns, and they will all be comma separated. You can use a keyword DESC for descending, and so in SAS, you use this keyword called nodupe for removing duplicates. To replicate that in R, you would use the distinct function to, whatever you've selected, and you want to say distinct up to that output. So that would basically just remove all your duplicates. And this is not even, so in SAS, there is this limitation that the duplicates have to be, sort of next to each other for this no dupe to work. But that limitation is no more when you're using distinct. So another example, I think I'll just take and probably leave the last one, is for filtering, where you could, in SAS, we give conditions where in a data step using a if clause, and, I would translate that as a filter function in R with the Tidyverse ecosystem, where you could, the only thing that sort of changes is the equivalence. So when you're testing for a condition in R, whether it's if else or filter, we, this is a way of identifying that, this is not an assignment. So this is a condition we are testing. So this is your column name, the value you want to test it for. And so this filter function is what it's gonna filter it. All right. So the next step generally is, you've worked with the columns, you've done some filtering. Now, a lot of times you would want to look at some aggregates, so accounts and summary tables and things like that. So you generally would use a procedure called procfrec, that stands for frequency. So it basically tabulates your data by, frequency of the data that you're passing to it by a given variable. If you pass the table table value to it, in the Tidyverse environment, you could simply use a count function. What that would do is, count all the values or all the number of rows by this job type. And although I think, like I mentioned, so the focus is on the Tidyverse section, but there are actually other functions that, other packages and other functions that allow for more such examples. And janitor table, like TABYL function, is another one that I use pretty often. So that's another one that you could add to your kitty. So this is an example by, when you're doing frequency by a one column, multiple columns, and, nothing really changes too much from the syntax point of view here. For summary, again, we're looking at, we could add group by, we could summarize by looking at, just trying to get the counts, or even sum or mean, or any of those, operations can also be performed. Then we have, so combining the data frame. So this could mean, adding rows to your data or adding more columns to your data. So which basically, boils down to, which really means so adding rows would basically resemble bind rows function, or in SAS you use set data. So you have a base data. You could use proc append, or you could use set to add or append rows to the data, which is assuming everything is in same structure. And when you're looking to add columns, basically for a certain set of, your key columns you have common in different data frames, and then you want to join them together. So the left join or right join is basically what you're looking for from the Tidyverse ecosystem. So what is called merge in SAS would translate to a join, certain kind of join in R. So how you in the SAS environment with the merge keyword, how you would identify whether you were looking for a left join or right join would really be based on what you have in your in operator. And so basically in operator defines like a in SQL, if you remember when you're merging, or it's actually, so SQL still, it's called a join. So it says, you give table aliases. So similar to that, you use in operator here, and you would want to give an alias to your data frames. And then depending on what you're giving in your, if statement of the merge that would give you a sense of whether it's so in this case, it's a left join. If you had, let's say in is equal to A and in is equal to B here, and let's say, if A and B was something that you had given, so then you're looking at an inner join. And, so all those different combinations in terms of sets, if you could imagine, is what we're looking at. Another highlighting. All right, so that's pretty much the big chunk of what I had to talk. And if I had time, I could cover how similar or different working with dates is. So in Tidyverse ecosystem, we have loop redate package, which makes it very easy. We have string R package, which makes working with strings a lot easier and smoother. And then we have ggplot2, which smoothens the process of plotting the data and gives you a very nice visuals. But I do want to part with giving some idea of how would you, or how could you potentially automate your tasks. So in SAS per se, there are loops, and then there are macros that allow you to do that. So this is just an example to talk about how SAS macro sort of corresponds or translates into an R function. So in essence, they are doing the same thing. You pass an argument to your macro, and similarly you pass an argument to a function. So if you are encountering a macro, which basically means you need to think about what is being repeated in the process, and then you want to translate that into a function, and all the things that are inside it are going to replicate to one of the things that we just sort of discussed in the previous slides. However, talking about loops, like I mentioned, so I want to sort of, this is going to be my last slide. So I want to just give a brief idea on how I can, either for simpler functions or when we have loops in that we're looking at in a SAS code, a lot of, and this is, from my current experience of one of the projects that I'm working on, is you could, depending on what you're trying to achieve, if it's a simpler if it's a simple calculation or a very small function, you could potentially achieve it using a helper function like across from the Tidyverse ecosystem, and you could work across, so you could perform a particular action across multiple columns once you pass that as a vector inside across. It could be a mutate or summarize, and it can run through that operation multiple times for each of those columns that you would pass. And if you're looking at something a little more complex, there is a chance that you want to translate the actual task into a function, and then you pass that function inside a map family of functions. So it could be map, map2, or pmap, and there are a few other ancillary family of functions, all of that come from per package, which in essence are very useful, once you get a hang of it, from the efficiency point of view, and also from the debugging point of view. So because it helps you reduce your task to a smaller piece, and then that what is it that you're repeating it over. That's where I think I would sort of end the discussion. And I hope I brought in some comfort, or I gave you some ideas as to how you could translate your codes, or how things can be made more efficient if you were looking to, or were on the edge of whether or not you should move your SAS codes, legacy SAS codes, to R. So that's all.
Thank you so much, Priyanka. Great talk. I really liked your slides. We have a couple questions in the chat. The first question is, you mentioned the R community as a reason you use R. Do you have any advice for new R users to connect with more R users?
Sure. So we have, I think my first interaction to the community was, I think, Our Lady Slack channel, which, you could, we could get you in from, if you share your email here, then there must be, our user groups in the whichever location you are in. I have been an active member of Boston Rug, and since pandemic, I think a lot more. And then I also got involved with R4DS community, which is, comes from, it got started because of the book R4DS, and it's a huge community now. And I think I'm a regular. I don't think I could have been where I am today without, these communities and without people just, helping you at any point of the time. I mean, at any point in day. So I think I owe a lot of my growth to the community.
Awesome. And then one last question. Is there anything in SAS you cannot do in R?
I would like to think no. I may, I guess I may have, from what I have experienced, I would say I've not seen anything that you cannot translate from SAS to R. From things that I've been doing past couple of months, I have seen that it only makes it more efficient. In fact, I could answer one thing, other way around, that I was thinking about earlier, and I forgot to mention, is that in R being an open source, tool, it has given a lot of other developers the place to build their own packages, and it also gives you ability to have your own internal packages when you're in a working in a company or in your team. So you in R you could develop your own packages and then have it where you can just put in your reusable functions and code, which I have not seen when I was working in SAS. So that flexibility. So if you had to use something, maybe a macro again, you would have to copy everything over from the previous project to the new one.
Awesome. Thank you so much again. Great talk.
Thank you so much.
So next on our speaker lineup is Hebah. Hebah's talk is titled Leveraging Open Source Communities for Professional Development. A few years ago, Hebah made a career switch and picked up R as a coding language without any coding background before. And despite being in an accredited program, everything Hebah learned about R and coding has been through the contribution of the R community and the help of its generous members. And so, again, her talk will be on how the community for professional development. So I'll let you take it away, Hebah.
So like Jessica said, I will be talking about leveraging open source communities for professional development. And I'm hoping that this helps new or early career professionals in data science, or people who are thinking of making the switch, or people who are looking to develop and grow their skills, professional skills in data science, and are looking for resources or channels to work on those skills. So a little bit about myself. I studied political science, comparative politics, and international relations, both in my undergrad and grad years. Throughout my academic career, I focused my degrees on research using both quantitative and qualitative research methods, and gained data analytics and statistical skills along the way. I took courses in econometrics and different research methodologies in the field. So I've always had that interest in research and data analytics and finding patterns and trends in data and gaining insights from those. But besides learning to conduct a research project and analyzing the results in Stata during a graduate course, I did not have any background in coding or data science in general. I never even had or showed any interest, mostly because I never grew up knowing that I could be, doing something like that. I didn't think it was possible for someone like me, like a woman working in tech or being a data scientist. But when I realized that my plan to become a social science researcher and academic was not working out, I knew that I needed to jumpstart my career and upskill and learn something new. So, like I said, since I've always had an interest in data analysis, I enrolled in an R for data analytics program to pick up coding and R from UCSD Extension. I came out of that program with RStudio installed on my laptop and knowing how to code, print hello world. That was it, unfortunately. So taking a little bit, a couple of steps back, looking at a bigger picture. To learn data science, there are 4 main paths, and those are outlined in Build a Career in Data Science, book and podcast by Emily Robinson and Jacqueline Nolas. This is an amazing resource that I recommend to everyone who is in the field or looking to build a career in data science. And my presentation will focus on learning on your own. So the book talks in detail and discusses the advantages and disadvantages of 4 paths: master's in data science, or taking a boot camp, or learning on the job, or learning on your own. But whatever path you take, the most important thing and usually the most difficult things to find, especially when you're learning on your own, is finding the motivation and the support. Having a sense of community, people to answer your questions, to help you to keep you on check with your progress and learning that skill. But like Priyanka said, with R, I think there's something about the R community. There's something special about them. There's this powerful and strong sense of community. And community in general is a powerful and uplifting force during a learning process. And like I mentioned, it's usually the most difficult thing to find during adult professional learning. And for a while after coming out of that program through UCSD Extension, I felt lost. I didn't know where to go. I didn't know how to really apply these skills. Of course, I didn't have the portfolio or the skills or even any direction to where I can apply these skills and have an experience to be able to work in the field. Somehow I cannot remember, I've been thinking about it for the past week. I cannot remember how I came across Our Ladies community. I think I was looking online for a community of coders, and then I stumbled upon the Our Ladies community, and I started joining their events, joined their Slack channel, and then I started also to join more online communities and learn to leverage those available resources to us. So these communities are either public communities like LinkedIn, Twitter, Mastodon, or private communities. All of them offer safe learning spaces, collaborative environments, shared resources. Within those communities, I still continue to find the support and confidence to progress in my career as a solo data scientist and R user. But private communities, specifically offer, I would say there's more chances that you can make more connections. You can meet people and have more, support that is specific to your needs. I've met wonderful people through these private communities. There's the Our Ladies channel, the Women Who Code channel, R for Data Science. I see that some people dropped that also in the chat. It's a really great resource available. The Data Visualization Society, which they also have their regular magazine, and very amazing, insightful articles that they publish regularly, and they share amazing data visualizations, very inspiring. There are also the communities or the Slack channels for developers like Observable or Posit. They have their own Slack channels, which I recommend that you check out. They have also their social media community groups. And someone mentioned the data science hangout from Posit that happens every Thursday. And that's also a great way to hang out with fellow data scientists who, like, every Thursday they share their best practices, what they're doing in their jobs, how they got there. You know, every presentation is different, and you get to interact and talk with them. So very quickly, I'll just go over how I leverage these resources usually. So follow social media pages of private communities. All these communities, you know, Women Who Code, Offer Data Science, Our Ladies, Posit, Observable, they all have their pages on LinkedIn, Twitter. I believe Mastodon also, they have their accounts there. So join them and keep up with their updates. Of course, don't join the Slack channels, because that's where you can post your questions, your you know, any troubleshooting that you need, any help with coding, that you can post there. And also keep up with their events and have questions for organizers, which you can post on their Slack channels. And like I mentioned, follow the accounts or social media accounts of companies like Posit and Observable. I just got my certificate today for SQL. I learned, you know, through the course offered by Observable. That was completely free, 4 hours. I completed the assignment and I got my certificate, and I learned SQL from one of the free offered courses from Observable. And that was an amazing resource that I was very grateful to have. What I would say, a very important thing to determine early on is your career path. Build a Career in Data Science book and podcast talks at length about the different job titles and different tasks you could be doing under each job title. So the data science field is very, you know, big, and it means different things, and they detail all these career paths. So determine what you want to do, because you know, that will help you set the path of what resources to follow, who to talk to, what jobs you apply for, and whatnot. And I think this is one of the most important tips here, is to follow these events that relate to your career paths, to the career path. There's constantly, every week, a lot of workshops and events and courses offered from all these open source communities that I mentioned. So, you know, keep track of those and attend them. I've learned everything I know from these workshops and events. I even learned how to use Quarto, which you know, which I made the slides, I created the slides on from a YouTube video that was offered by you know, several of the contributors from these communities. Also, public pages on LinkedIn, like Data Analysis LinkedIn page and the Data Analytics Study Group, which I've left I have the links here for those, and I can share with you if you'd like. These are public communities that sometimes pose questions, and people just share publicly what their best practices are, and what they recommend, or what they're doing, and what their thoughts are in their jobs. Look out for community contributors and community leaders and event participants. Follow them on social media, because they, most likely than not, they have their own blogs, which are rich in information. You can look at what they're doing. I learned so much by going to their GitHub and copying their code by typing it myself. So that creates the muscle memory, or learning what they're doing and how they created that that piece in data visualization, or how they wrangled their data. That was one way of helping me know exactly how they applied these functions and tools available to them to create their, to wrangle their data and create their visualization. Podcasts are also a great resource to stay up to date with industry and get introduced to industry leaders and learn from their experiences. I will share a link here to a list of podcasts and data science that I've created in my blog. And always engage online, ask questions, answer questions. This is also another link to a YouTube video by David Robinson. He's talking here about how, or the importance of making your work public. Put yourself out there, answer questions that on Stack Overflow or on Slack channels when people are asking for help. If you can, provide that help, do that. Share your work, share what you've coded, what you've created, and make your work public. And finally, don't be afraid to reach out to people, ask for help. I want to thank, this is an opportunity to also thank a lot of people who have helped me. I've posted questions that I've received answers to. I have met with people who have helped me create even this presentation. I have regular meetings with Tanya Shapiro. I reached out to her and I was like, hey, I'm lonely here. I would like to have a mentor or someone who would help me build this career. So yeah, reach out to people. Everyone in this community is helpful. And thank you. These are my social media accounts, which I'd love to hear from you. And if you have any other suggestions for resources, open communities, what worked best for you to learn or develop your coding and data science skills, please share with us.
Great, thank you. We have some questions. Actually, someone directly wanted to say thank you for sharing your story. I related strongly to not thinking a career in coding data was possible for me. I wish I had known sooner I could. So for the questions, do you have any recommendations for finding data to practice with?
Yes, there's the Tidy Tuesday, which every week they share data, open source data, and it's like a public challenge. Use the data, do whatever you want with it, and then share it on social media and use hashtag Tidy Tuesday. There's also, I think it's called Kaggle. Did I pronounce that right? So it's a website. Trying to get all the links here lined up. So yeah, there's Kaggle also, which you can access all kinds of data to use. There are some websites or other businesses that have their data open source, like Economist. The Economist has their data available for public use. Some museums. So if you have an interest in something or a certain business organization, sometimes they have their data available for public use.
Okay. And do you have any tips for asking for help online, like on Slack?
Yes, be as specific as possible. Obviously, be kind, be courteous, respectful, but also be as specific as possible. Try first solving the problem on your own, but if you feel stuck, then be direct and brief. And like I said, as specific, like what is where are you stuck in that code? Offer reproducible code for people to be able to run the code themselves or see where you're really stuck. so they can give you the help that you need. Also, if you need career advice, be clear where you want to be and be clear what kind of help you need.
Great, thank you.
Okay, we can move on to our next speaker. Our next speaker for this talk session is Kiki Zhang. The title of Kiki's talk is Imaging R, an interactive web application for visualizing multimodality imaging data using R in Shiny. This talk will be about an R-based web application that provides interactive web image processing, analysis, and visualization, and it is an application that Kiki developed. So I will let you share your slides and take the floor.
Okay, thanks for inviting me and great talk so far. Okay, super excited. So hi everyone, my name's Kiki and I study biomedical engineering at Johns Hopkins University. I'm very glad to be a speaker at the R Ladies event today, and I'm going to talk about how I develop a time series dashboard to visualize neuroimaging data using R Shiny. So to understand the functions of our nervous system, such as motor function and emotionality, it's very important for us to correlate behaviors and neurophysiology. And in general, how do our brains produce appropriate behaviors under certain circumstances? One way to approach this is to use animal behavioral testing, which we observe neural activities while monitoring behavioral output from the animals. And this provides us with information on the brain regions and the timing of neural activities. And in order to do this, we use a miniature microscope, as shown here below. The microscope is around the size of a coin, and we mounted it onto a mouse head and continuously imaged the mouse for days to record high resolution data. So we collected data directly from the experiments. And the next step is to analyze those high dimensional neuroimaging data synchronized with behaviors. And additionally, the multi-channel miniature microscope offers us 3 options to observe changes in the mouse brain over time. And from left to right, we have a fluorescence channel for imaging neural activities and a laser spectral, and iOS channel for imaging cerebral blood volume, and a laser spectral contrast channel for imaging cerebral blood flow. These data help us capture the time evolution of neural activation and hemodynamic response in terms of change in cerebral blood volume and cerebral blood flow separately. And I will just call them CBV and CBF in short. So local CBV and CBF changes accompany neuronal activity are important neurophysiological parameters for functional brain imaging. And as a result, these 3 parameters will be set as the main metrics for my dashboard development. So with the data from the 3 channels, we can represent more of the information simultaneously for exhaustive data visualization. But the high dimensionality of data and the complexity of computational models make visualization a big challenge. And if you're familiar with ImageJ, you know it's a very powerful program for image processing, but its user interface lacks the flexibility and convenience for users to navigate, especially for people who just hop on ImageJ and imaging processing pipelines. So the plots generated by ImageJ are static, which means the users cannot manipulate the data or have the option to change features directly on the graph. So my initial goal for this project was to create a dashboard that incorporates the basic imaging processing functions ImageJ has with the interactions capabilities that allow users to develop a visual data story. And my first thought was to use Grafana to solve this problem. So Grafana is a web application that is very popular among financial institutions to monitor market data, especially time series data. But apparently it was a failed attempt. And that's why I'm sitting here and giving a talk about how powerful R is, not Grafana. So after months of trying, I found it hard to interrogate biological or imaging data using Grafana. And the reason was simple. So because we didn't have a well-established database with enough time series data for Grafana to visualize it. So now comes my second option. And finally, today's topic, RShiny. But why did I choose the RShiny platform? And how does it differentiate from other app development tools such as Grafana or ImageJ? Where first you may want to know what is RShiny. So Shiny is an R package that allows for efficient web application development. It executes R code on the back end, and the number of its application is growing fast in the large R community for bioinformatics. And there are many different biological web applications that have been developed using RShiny. And here's an example. So this is a genome browser dashboard. And if you're familiar with genome data analysis, this interactive feature for circus plot is very useful. And for my own design, I think Shiny is great for creating interactive plots with lots of possibilities. And it's also very flexible for design and prototyping, as you can change the layout, add or delete different widgets tailored to your needs. And because the dashboard is a GUI, a graphical user interface, users who don't have any programming experience can still work through the app. And additionally, RShiny can be extended to other platforms and languages such as Poly, CSS, or connected to a database to perform a query. So now I want to talk about my design criteria for creating the dashboard, considering one of my biggest goal is to customize data visualization. So where do I start first? From two perspectives. First is about the platform. What kind of platform should I use to make a dashboard from scratch? As I mentioned in the previous slide, a UI, a graphical user interface, will enable users to view, manipulate, and toggle through programs at the same time. So the whole dashboard is presentable in this case. And another consideration for the platform is that it should allow for interactive processing. For example, if a user changes one parameter, then all the plots involving that parameter in the computation should be regenerated automatically on the dashboard. And now considering the second perspective, I also want to pick appropriate statistical algorithms that give rich analysis, but also can be applied to more generalized neuroimaging data sets. And basically includes two kinds of signal analysis, the spectral density and cross-correlation. These two methods provide a quick and quantifiable way to observe individual variation in sub-second dynamics of brain activities. And I'll zoom into the details of these two approaches in the later slides. And here's the overall design workflow for the dashboard. First, we have the raw imaging data collected from the experiments, and then displaying the images, and the users can select regions of interest on the plot. And the time series data will be generated based on the user selection. And by looking closer to the time series data, the user can highlight relevant information for further analysis. And I'm going to show you different sections of the dashboard based on the workflow. The first step asks the user to upload data, and the data set should satisfy the following requirements: 3 channels, imaging data in TIFF format with maximum input to around 2,000 frames per experiment, and the data will be automatically normalized to the 0 to 1 range for time series analysis. The normalization sets the 3 parameters in the same range, which will benefit for the time series analysis later on. And then to display the image stack, user can use the sliders to adjust the contrast of the image being displayed. Users can set the values to enhance the visual output of the image and turn the original image into its ideal display. Then the selection tab allows the user to pick a specific channel to display. As Shiny is interactive, the image stack will be automatically displayed after user selection. And next, the dashboard will display the images for the 3 channels by taking the mean value across all frames And shown here are the 3 images corresponding to the 3 channels on the neuronal CBV and CBF. The user can draw the regions of interest directly on one graph, like this black box shown here. And this is called brushing. And the other 2 graphs will have the mimic brush generated automatically with the same region annotated as these 2 pink boxes shown here. And defining a specific region is very important because it helps us filter the most representative data and exclude those irrelevant ones when choosing the data for modeling. And then the user can visualize the time series in regions of interest, for example, to see the neuronal activities over time. What is graphed on the right side is a time series plot. It computes the mean intensity value of the region selected across all image frame. And you can depict those image frames together as a stack, with each image frame from this one large stack is considered as a single timestamp. And other users move the brush, the pink box here, or select a new region on the left plot, the time series will be regenerated automatically. And shown on this plot are 3 different traces of data, which are neuronal CBV and CBF corresponding to the region selected by the user. As time series can be represented by decomposing them into a sum of more like elementary signals, I'm interested in determining the spectral density of each signal. And to do this, I perform the fast Fourier transform on each time series as shown on the left and converted the signals in the time domain to the frequency domain. And show here's a plot of the power as a function of frequencies. It gives the distribution of power into frequency components composing that signal. And the comparison of the power spectra helps to characterize the correlations between the 3 different variables, so we can know which variable has the highest amplitude at a given frequency. And I'm also interested to see if there's a correlation pattern between the 2 signals over time. So by performing time lag cross correlations, users can compute cross correlation between the 2 signals. And this helps us to identify directionality between the 2 signals, such as a leader-follower relationship in which the leader initiates a response that is repeated by the follower. And the selection tab here gives the user the freedom to compare 2 different signals or variables. And from the graph, we can extract a sense of which signal occurs first by looking at cross correlation. And in the case of this plot, we are comparing neuronal and CBF as shown here in this. And we see the peak synchrony marked by this orange dotted line in the middle, meaning it has the highest cross correlational values that occurs at a 0 time frame because it's in the middle. And this analysis helps us to assess neurovascular coupling patterns easily. And in summary, the imaging R dashboard functions as a UI that allows for interactive processing, and these features make it distinguishable from images complex layout and more hardwired image processing procedures. The 2 signal analysis methods offer a general but useful solution to quantify variation in neuronal dynamics, and specifically spectral density gives us the spectral energy distribution of each signal that will be found per unit time. And the time lag cross correlation showed us more straightforward interaction dynamic patterns to see if one signal leads the other. And last, I want to talk about the further development of this dashboard in the future. So there's 3 different aspects I can work on. First, if I want to visualize more real-time, like huge data sets, the dashboard can be connected to query an external database. And the second option is to deploy the app, meaning sharing the app with multiple users so they can all access the dashboard without running the codes in R. And Besides, I can include the features of the dashboard, for example, giving the users option to choose multiple regions to analyze. So we can look into how different variables evolve over both regions and time, and compare the observations between the two different sizes of regions. And I hope with these new features added, the dashboard can be applied to more different scenarios. For example, not just take the 3 specific variables the neural node and have hemodynamic variables as metrics, and will have a greater impact on a larger community of users. And thanks for listening. So questions? And also feel free to connect me on my LinkedIn page. And here's a QR code.
Great, thank you. Yes, there are some questions. It's actually a question about getting access to these presentations. And I think when the meetup is over and we put the recording on YouTube, we'll probably have a link to the slides if the speakers allow. But for you, there's some questions. Imaging data can be really large. Do you run into any issues with the performance speed of the Shiny app?
Oh, so when I run it locally on my computer, I feel like it doesn't hurt, but like when I try to deploy the app, I actually made some experiments trying to deploy my app so like other people can get access to it, but I feel like it's kind of hard when you upload like huge data sets. I guess it's more, it has nothing to do with the data set, but more to do with how you deploy the app and like which server you are hosted, which server like you're going to use to host the app.
Great. And can you use this application with clinical data?
I haven't tried with clinical data yet, but like as long as it satisfies like the requirement for the data input, I think this can work properly.
Great, thank you.
Okay, I'll go ahead and introduce our next speaker. Our next speaker will be Abigail, and the title of Abigail's talk is Using the OpenAI API with Your Prompt and Your Data. And in this talk, Abigail will be showing how they're using our OpenAI package to work with the GPT-4 API. So you can go ahead and share your slides and take the floor, Abigail.
Here we go. Okay. So hello, I am a data scientist, and over the years, I've done a lot with natural language processing, which we'll talk more about. But when ChatGPT came along, that was really the task that I was really interested in, was things like how do we summarize a bunch of data, or how do we do what's called named entity recognition, where we're interested in specific kinds of things, like we want all the people in some text or all the places. And so that was sort of what got me started using the OpenAI API, as opposed to just sort of the ChatGPT graphical user interface where you're copying and pasting. And I'm going to talk about a slightly different task today, but that was what really got me into it, and I've been using it a lot and writing a lot of code with it. And there's this R library that you can do that with that we'll talk about. So this is really the takeaway from this: is if there's a thing you want to do, but you want to do it repeatedly, like summarizing text, you can do that using the API, and you can basically have a prompt like summarize or find all the names of the people in this text or whatever you want. And with a very small amount of code, you can iterate through that text and concatenate it with your prompt, the summarize or whatever it is. And you can get back your results using the API. So the project for this that I'll talk about was generating fake resumes, which is that's like a weird project, right? But it was part of a larger project where the goal was to actually evaluate resumes, was to be able to say, like, is this somebody we want to interview or not interview, that kind of thing. Can we get ChatGPT to respond the same way as our HR people? But in order to do that, I needed some fake resumes, because when I wanted to share this project out, I wasn't going to share it like people's real resumes. We weren't going to be like, this one was good, this one was bad. So I needed some fake resumes. So my inputs here were a prompt that's basically like, generate me a fake resume. And then I had this CSV file that I wrote. I'll show you a little bit of it. And I have a column that's fake names, I have a column that's academic backgrounds, and I have a column that's basically a bio that I wrote for everybody. So like, here's a little about this fake person. And then the outputs are a fake resume for each fake candidate. So here is what some of that sample input and output text looked like. So like, for instance, I wrote a little consultant's bio. And you can see like this isn't very formal language, like that's fine. I give them a job title, I give them, you know, a college major, I give them a description, and this gets concatenated with my generate me a fake resume text. And this is the excerpt, it's kind of small, but this is just the part from their current job. So write me like a whole thing, but this is the description wrote me of their current job. And it's like pretty good, like it's fine, like it's I've looked at a lot of resumes over the years, like I wouldn't look at this and go like that's clearly fake. I would be like, okay, this is a resume. And you can see like it uses language describing technical tasks in a way that like somebody might use, and it also is like kind of the consultant speak that I asked for. One thing was the resumes it generated of me were less varied. Like they all kind of had this same sort of format where like, here's some, you know, here's a description of my job, and then like here's a list of like languages or tools I use. Certifications, for some reason, is really big on that. Whereas like real resumes are much weirder. So like I saw a real resume once where the person wrote almost nothing about what they actually did in their job, and then they were like, but also I do all these open source library stuff. And I read that and I was like, oh, this person like clearly knows what they're doing, but the resume was super weird. And I don't know if we did send that to ChatGPT to evaluate it, and they were like, no, this is a bad resume. Yeah, the resumes we got out from this were definitely kind of narrower, but they were like pretty good. They were like good enough for the project. So the process here is basically you have some text data. So in this case, I had a CSV file, but like wherever your text lives, you know, pull your text from there. It can be, you know, a bunch of text files. It can be data you're pulling from API, whatever. And then you're concatenating it. So you're basically pasting it together with your prompts, your summarize this or generate this or whatever prompt. And then you're sending that kind of block of text to the OpenAI API. And then you're getting back a result. And then you're going to put that result basically in like a table or data frame or whatever. And then you're going to evaluate it. So that could be informal, like in this case, I looked at the resumes, I was like, these are pretty good. Or actually initially I was like, these are not so good. They were like too short. So I changed my prompt a little. I was like, write me more detailed than you want to, whatever, like keep going. And then, you know, iterated, generated again, or you can do more formal kind of assessments. So like one of the tasks that I've done with this is I have a classification model. So that was the up or down on the resume. Like, do we like this? Do we not like this? And so for that, I had like actual label data. Like before I had ChatGPT evaluated, like I evaluated the fake resumes as good or bad. And then I was able to easily compare basically each prompt result with the up or down that I'd given it and to see how accurate it was. And so for that, I use like a really kind of a formal, you know, false positives, false negatives, true positives, true negatives, like grid, where you see how well it did. So basically you read in your text, send it to the API, you get back some results and you like them or don't like them. Okay, so this is just the visual way of looking at it. You have sort of a stack of data or a stack of papers, whatever. You have a prompt, you have some code, you send it to the API, you get back a table. Okay, so other sort of use cases for this, I talk about text summarization because it's a really good one for this. So we use that in the context of something like summarize the candidate's software development background. So this was for software developers. And it gives you back something. Classification, so I've used this for job listings, like is this a data science job, is this not a data science job, or something like what topics is this text about? So those are all kind of classification things. And then named entity recognition, so something like what tools and software are in this job listing, or what locations are mentioned, that kind of thing. These are all good use cases. I'm gonna say like, the extent to which these were doable easily before ChatGPT really varied. So named entity recognition is sort of the easiest. There's a library called Spacey. There's an R binding for it. And if you wanted names or places, you could fairly easily get them. I tried it for tools and software. I didn't do a very good job. Locations probably could handle. Text summarization, there were a number of models previously, varying levels of good, but you could do it. Classification was really tough. So if you had a really kind of well-trodden classification text, like sentiment analysis, like we want to know like how positive or negative is this text, or like topic modeling, you want to know what it's about, then you would probably be able to get that without like a ton of work. If you wanted something like, is this job a data science job? You were going to be like labeling a lot of data in order to get a model working, and it was going to take a long time and be kind of a pain. And with ChatGPT, it's this sort of like pre-trained everything model. Like it doesn't always work, but you can, at least is a shot at basically just writing a prompt and saying, is this a data science job, or is this a good resume, or whatever? And you'll get results quickly, and in some cases quite good, in a way that previously would have been just a lot more difficult and a lot more effort. Okay, so this presentation, my slides, and my code are on GitHub. There's my email address. There's my blog where I write about this stuff. And I'm one of the data science DC organizers. We have actually lightning talks coming up in August 22nd. So I will shill for those as well. But yeah, questions?
Great, thank you. Have you tried different OpenAI models other than LLM to make fake resumes? Did some work better than others?
So I used 3.5 and I used 4, and 4 was better. I used both for evaluating resumes. I think they're about the same. I don't really remember. Names identity recognition was way better in 3.5. Don't know why, kind of weird. But it was better at giving me the format that I was asking for, which is basically like, just give me software tools and programming languages. And it gave it to me in like a really clean output, whereas 4 didn't. I'm using open source models now. So this is the next thing, is the Hugging Face models, because we can run them on like our AWS SageMaker resources, like totally like, in a box for like 4 clients, so that if like the client doesn't want to send their data to OpenAI, then we can run them there. And I'm not using any of the really big ones yet. We're just trying to get infrastructure working, but that's the next goal is, and then we'll, evaluate them against each other, like the OpenAI ones against the open source ones, and see how they do.
Cool. And what do you think best use of LLM are today for data science?
Yeah, I mean, basically, if you're interested in natural language processing, like it really was like there were just like all these things I'd had questions about previously, or that I'd done kind of in an ad hoc way that wasn't that great. And then it was like, okay, now we can just like do this. Like if you have a classification question involving text, like try it. And then yeah, other things like text summarization, where there's a ton of different models for it that are open source as well. I think like the stuff that you'll be seeing in all the tools you work in, whether it's word processing stuff or coding stuff, like these will all be built in, and there's all this interest in like the agent stuff that like what actually does things, and that I have a lot of security concerns about, and I'm curious. I'm not building any of that, but the NLP stuff is just really like low risk, because you're not connecting to anything. Like for our hiring stuff right now, like there's a human in the loop on all of this, so like we're not hiring on the basis of like what the model said. So yeah, just like anything with text data, like if you're interested in studying it for anything, like it's just super compelling as a resource.
Great, thank you.
We have one more speaker for this evening, and that will be Arati. And Arati will be speaking on a guide to using Tidyverse Style Guide. And the title of Arati's talk is Tidyverse Style Guide. So I will let you share your screen and take the floor.
Thank you. Can you hear me? No, my mic is sometimes.
Yes, we can hear you.
Okay, great. So hi, everybody. My name is Arati Krishnamoorthy, and I am one of the organizers of Our Ladies DC. So if you are in the DMV area, please do reach out. Please feel free to connect even otherwise, but especially if you are in the DMV area and if you would like to be a co-organizer for Our Ladies DC. Okay. My talk today is on the Tidyverse style guide. So I will start with a quote from Hadley Wickham. Good coding is like correct punctuation. You can manage without it, but it sure makes things easier to read. And so that takes us to why we need a style guide. So of course it makes things easier to read, but it's not just about the aesthetics. Anyone want to take a shot in the chat perhaps on what else a style guide might help with? Why do we need a style guide? It's kind of late here, but for those of you who are still listening, no? So it makes code robust and efficient. And of course, it makes code also easier to reproduce, and it makes it easier to collaborate. Yes, that's right, Alice. And easier to maintain. And so essentially by using a code guide, you are being kind both on yourself and on anyone else who's trying to read your code, right? So starting with the golden rule, so to speak, of the Tidyverse style guide is that consistency is key. In some cases, you'll see that there are two options to do something. And so it's best to pick one option and stick with it. So with that, we'll launch right away into the style guide. So first, looking at variable and function names. So of all the many different options available, the Tidyverse style guide recommends the snake case. So uppercase letters and, lowercase letters and numbers and underscores. Also, it's good to be concise and meaningful. And so, for example, day_1 is good, but day1 with capitals thrown in is not. Another part of the guide is that says that it's good to use verbs for function names instead of nouns or anything else. So for example, add_row is good, permute is good, but row adder or permutation is not good. So what about using a period instead of an underscore? And this is something I have been guilty of doing as well. In fact, as I was doing this, I realized that if you use I think it's the clean names argument in Read CSV, it does clean up the names by adding a period when there are spaces. What does the Tidyverse style guide have to say about that? Doesn't like it. So don't do that, use underscores. Moving on for library calls. The guide says load all add-on packages at the start instead of sprinkling library calls all throughout your code, something that I have done, or having hidden dependencies that are loaded in a startup file. Going on to comments. So comments start with a hash and a space. And then when you think about when you write a comment, so the examples that are shown here are actually not great examples because the guide says you don't use a comment to explain the what or the how. Rather, you use it to explain the why. You'll also notice over here that a lot of the code and the comments are pretty long, and that's something that the guide frowns upon. And so it says limited to 80 characters. And the way to do that, to help yourself do that, is to go to, if you're using RStudio, to go to Tools, Global Options, Code and Display, and then you can check the box against Show Margin. The Tidyverse style guide recommends 80. I kind of like using 100 for no reason, but the recommended number is 80. Okay, moving on to spaces. So there are many different options, right? And so anyone want to take a guess in the chat, which of these do you think is a good option for the Tidyverse style guide? 3, that's right. So a space comes after a comma, not before. So 3 is good. 1, 2, and 4 are not. Looking at another option, so if these two, spend a few seconds thinking of which one do you think is a good option. Put it in the chat if you like. 1 or 2. Yeah, it is 1. So the style guide says that you need a space both before and after the parentheses when you use it with an if, for, or a while. Moving on. 3, 4, and 5, which do you think is good? Any guesses? Which one looks good to folks? 3, 5. Yeah, it turns out that for functions, a space after the parentheses, so 3 is good, not 4, not 5. And I kind of use 5. There's more on spaces. This is not the end. So spaces before and after for most infix operators. So these are good where there are spaces before and after, but this is not good. And then there are a whole bunch of exceptions. And so if you're wondering, how am I ever going to remember all of this? Of course, there is a package. There are 2 packages that can come to your help. There's stylar and lintar. And these 2 excellent packages, once you install them, will create add-ins in RStudio, which I just love. So with stylar, for example, you can select a section of the code and then ask it to style that selection per the Tidyverse style guide, and it'll do that for you. You can do that for the entire file or package as well. With lintar, which I kind of like better, it will not automatically style it for you, but it will tell you where you are in conflict with the code. Sorry, with the style guidance. So like you can see here in this image. So I could really end the talk here, and I did consider ending the talk here and saying, okay, everyone, go and try out these 2 packages on your code and see what it tells you. But I have the mic. So I will highlight a few things that have tripped me up, a few more things that have tripped me up in the past. So one is function calls. So when calling functions, then for the data arguments, so over here mean 1 to 10, the guide recommends omitting the name. But when you, for other arguments, when you override the default, it recommends that you use the full name. And then, oh, this one is such a doozy. So always use double quotes, no single quotes, but except when the character vector already contains double quotes, in which case you use single quotes. But then if it has both double and single quotes, then you use double quotes again. So again, use styler, use linter, and correct your code. Or rather, style your code, I guess. For indentation, there are two options, both of which are acceptable. One is the function style indent, where if you see over here, all of the arguments are lined up one below the other. So this is okay. And then the double indent, where the arguments start on a line below the function, but then all of them are have double spaces. That is okay as well. The function style indent is preferred when it fits within that 80 character length. And again, consistency is paramount, so pick what works best for you and stick to it. And then finally, pipes. So for pipes, a space before the pipe, a new line after the pipe, and each line indented by 2 spaces. Yeah, in this one, avoid this operator, instead explicitly assign using just the regular pipe or the base R pipe. And then, of course, there's so much more that I have not covered. And of course, the Tidyverse Style Guide website is the best place to go and look at all of this. And again, those 2 packages that I mentioned are great resources to use. So with that, I will stop. Thank you.
Great, thank you. There are some questions. How can I convince my coworkers and boss that we should use a style guide?
Yeah, that is a great question. I would say, I think, and this is something that I kind of thought I would do for this talk, but I didn't get around to doing. I think the best way is to show examples of code that is inconsistently formatted versus code that is consistently formatted, kind of side by side, and show how much easier it is to look at and understand code that is well formatted and consistent, right? The key is consistency as well. I think that's probably the best way. I don't know if anyone else has any other suggestions, then please use the chat or come off mute. But to me, I think that's a good way. Especially if you have to collaborate a lot and look at each other's code. A style guide is so important. It makes it so much more efficient, right?
Great. Can you give an example of a good comment that says why and why not? It says why and not what, sorry.
Yeah. So, I mean, I'll say that when I write comments, I tend to do both, depending on whether if it's obvious or not, about whether the what is obvious or not. I suppose the why would look at why. So when checks, for example, when I do a lot of data wrangling and then I run a check to see if the code is doing what it is doing, then something that explains what it would be a why. Like, why are you running this check? Yeah, I don't know if that's a good response, but it's.
Okay.
Yeah.
And sorry, last question. I feel like the most common error Lintar throws at me is trailing white space. Is there any way to get rid of these automatically?
Yeah, not that I know of. I've got that a lot as well. And that's not to say it doesn't exist, but not that I know of.
And we just got one more question. Do pipes deserve one line per operation, or is it something like data frame pipe selects pipe arrange in one line? Okay.
I'm sorry, can you say that again?
Do pipes deserve one line per operation, or can you have what? Yes, okay.
Yes, one line per operation. I think the only time when the style guide recommends that, actually I may misspeak on this. So it's best to look at the website, the style guide website. Sorry, I'm not like being super helpful, but that is the best place to look at for this. But in general, yes, one line per operation. I kind of seem to remember that there is some exception to this, but I can't remember what the exception is. Yeah. So look at the website.
Great, thank you.
Great. That is a wrap on our lightning talks for this evening, everyone. I'd like to thank all of our speakers for taking the time to prepare and present on your art projects this evening. All the talks were incredibly impressive and diverse. And I'd also like to thank everyone for joining us. And I just put this slide up as a reminder for the 2 events coming up, July 13th and July 20th.